one of the assignments, one of the problems, I should say, in our assignment this week asks us to write the equation of a circle, and we're given the center of the circle and a point on the circle. So I wanted to make a quick video to remind you how to do that. Let's take a look. So the first thing that you need to have in your back pocket is the general equation of a circle, and you need to be familiar with how to manipulate that. So the general equation is x minus h squared plus y minus k squared. Those are quantities in parentheses. And then that equals r squared. And I usually have to take a little time to convince students that this is a fill-in-the-blank situation. We write out all of the white ink, and then we replace the red, blue, and green ink with numbers. So you're basically going to fill in the blank for the value of h, you're going to fill in the blank for the value of k, and you're going to fill in the blank for the value of r to write this equation. Now, what you need to then know is what the heck are h, k, and r? Well, the center of the circle is located at the point h, comma, k. So the h is the x-coordinate of the center, and the k is the y-coordinate of the center. The r is the radius of the circle. So the radius is r, and then what we'll do with the radius is we'll square it. Or, as a shortcut, if we happen to compute r squared, we'll just put it at the end of this equation. But those are the basics of the general equation. We're going to fill in the blank for h, k, and r. The center is hk and the radius is r. Let's see this thing in action. So here's a problem that's very similar to the one in the assignment. It says find the equation of a circle with center at the origin that passes through 2, 6. Well, the first thing we want to point out is that we're given the center. The center is the origin. And you just have to remember that the coordinates of the origin are 0, 0. That means that our h is 0 and our k is 0. So we've got two of our variables, two of our blanks already filled in. H is 0 and k is 0. To find r, we're going to need to find the distance between the center, 0, 0, and 2, 6. Let me just draw a quick sketch of what I mean here. Here's the circle. Pretend that's a circle. This is 0, 0, right? The center. And then there's some point 2, 6 out here that is on the circle. And I need to find out how long this segment is so I can find the value of r. And to do that, we'll need the distance formula. Or we could just use the Pythagorean theorem, which is basically another version of the distance formula. So what I'm really going to do is just figure out how far this is and how far this is, and I'll do a squared plus b squared. And you can see from the coordinates here, from 0 to 2 is just 2, from 0 to 6 is 6. So my radius squared is just 2 squared plus 6 squared. And my radius squared is going to end up being 4 plus 36, which is 40. The radius itself is the square root of 40, right? If we were doing the distance formula, it would be the square root of 2 minus 0 squared plus 6 minus 0 squared. But our formula doesn't need r, it really needs r squared. So sometimes it's quicker to just solve for r squared. And then what we do is we write out the formula for the circle. So x minus 0 squared, right? H was 0, plus y minus 0 squared, k was 0, equals r squared, which was 40. And then usually we simplify x minus 0 and y minus 0, since those are easy to compute, and we simply end up with x squared plus y squared equals 40 for the final equation, the simplified form. That's it for this problem. We fill in the blanks for h and k. I gotta squeeze this in here. And we're really looking for r squared here at the end. So sometimes it's faster just to use the Pythagorean theorem rather than the distance formula. However, we should also practice an equation where the center is not 0. So I'm going to do that problem next. So in this problem, we've essentially moved the center. And so we're looking for the circle that passes through the circle at center 1, 2. This is the center that passes through 5, negative 4. Remember, right out of the gate, we already know what h and k are. I'm told that the center is 1, 2, so h is 1 and k is 2. That's good to know. We filled in 2 of the 3 blanks that we need to fill in. Now to find r, we're going to have to do a little more complicated calculation this time. The distance formula, if you'll recall, is the square root of x2 minus x1 squared plus, that's an x, y2 minus y1 squared. Now we, again, remember from the other slide, we really want to find r squared, so we can simplify this to r squared equals x squared minus, or x2 minus x1 squared plus y2 minus y1 squared. There's no reason for us to take the square root and then square it again to put it into our equation. So I'm just going to solve for r squared. Okay, so what are these x and y values? Well, we're just going to have to identify those. So the first point we see here is 1, 2. I'm going to consider this x1 and this y1. And the second point we see is 5, negative 4. I'm going to consider this y2, x2 and y2 for negative 4. So we'll fill in these blanks here. I said x2 was 5, so I'm going to put 5 here. And I said x1 was 1, so I'll put that there. And I'll have to do that math and then square it. I said y2 was 2, and, y2 is not 2. Oops, and now I just highlighted it instead of erasing it. Okay, trying to erase some stuff here. Hopefully they'll show up right on the video. Let's do this again. y2 is negative 4. We have to keep these in the correct order. So if I put 5 first, I have to put negative 4 first. And y1 is 2. When you compute 5 minus 1, you get 4, so this is going to be 4 squared. And when you compute negative 4 minus 2, you get negative 6 squared. Be careful with this negative 6 squared. Some calculators are pretty fussy about the order of operations. If you want to square negative 6, you have to include it in parentheses. If you can do this math mentally, then you're okay. So let's just finish this off. This is going to be 16 for 4 squared plus 36 for negative 6 squared. And that adds up to 52. Now remember, we just computed r squared, so that's the number we'll stick at the end of our equation. So now we're ready to write the equation. We have x minus 1, because 1 was h, squared, plus y minus 2 squared equals 52, and we're done. We have filled in the blanks for the general equation for a circle. And that's the goal for this particular problem. Okay, I hope this helped, and if you have any questions, you know how to get a hold of me. Take care.